Intermolecular forces. So what are intermolecular forces? It is a force that holds the molecules together, which can be repulsive or attractive. It also accountable for the properties of a substance, and it explains why substances exist in solid, liquid, or gas state at a room temperature. Gases. The average kinetic energy of gas molecules is much larger than the average energy of the attractions between them. Liquids exist because there are intermolecular attractive forces which are strong enough to hold the molecules together, but without much odor. Substances exist in solid states because the intermolecular forces or intermolecular attractive forces are strong enough to lock the molecules in place or in high order. Interionic forces. It is a force that holds the ions together. This theory was discovered due to the Arrhenius theory having deficiencies. Arrhenius theory states that ions exist in a solid substance and dissociated from each other once the solid dissolves. Interionic forces. Interionic attractions are when an ion is surrounded by an ionic atmosphere which has a net charge opposite for its own. For example, an ion would be completely surrounded by ions mostly composed of cations or the positive ions, and the cation would mostly be surrounded by ions of anions or the negative ions. The ionic atmosphere decreases the mobility of each ion by exerting a drag on it, which in turn also decreases the magnitude of colligative properties. The ionic atmosphere cannot be created nor destroyed. Intermolecular and interionic forces of attractions. What are the types of interactions and the interacting particles for each interaction? First is dispersion. Interacting particles are all molecules, especially the nonpolar molecules. Next is the dipole-dipole interactions, which involves the polar molecules. Next is the ion-dipole interaction. Interacting particles are ions and polar molecules. Next type of interaction is the ion-ion interaction, which involves the ions, especially the cations and anions. Last is the hydrogen bond. Interacting particles includes nitrogen, fluorine, oxygen bonded with hydrogen atom. Okay, so there are four types of intermolecular forces. First is the dipole-dipole. Second, ion-dipole. Third, dispersion forces. Fourth, hydrogen bond. The first three types are known as van der Waals forces. On the other hand, hydrogen bond is a special type of dipole-dipole interaction. Johannes Diederik van der Waals. He was born on November 23, 1837 in Leiden, the Netherlands. In his 1873 thesis, van der Waals noted that the non-ideality of real gases and attributed it to the existence of intermolecular interactions. Okay, so let's first discuss the first intermolecular forces, which is the dipole-dipole interactions. Dipole-dipole interactions results when two dipolar molecules interact with each other through space. When this occurs, the partially negative portion of one of the polar molecules is attracted to the partially portion of the second polar molecules. This type of interaction between molecules accounts for many physically and biologically significant phenomena, such as the elevated boiling point of water. So what is the definition of dipole? Molecular dipoles occur due to the unequal sharing of electrons between atoms in a molecule. Those atoms that are more electronegative pull the bonded electrons toward or closer to themselves. The buildup of electron density around an atom or discrete region of a molecule can result in a molecular dipole in which one side of the molecule possesses a partially negative charge and the other side is partially positive charge. Molecules with dipoles that are not cancelled in their molecular geometry are said to be polar. Okay, so the dipole-dipole forces. Dipole-dipole forces are attractive forces between polar molecules. Molecules that exhibit dipole-dipole forces are attractive forces existing between polar molecules. Molecules that can exhibit dipole moments such as hydrogen chloride. Because there is an unequal sharing of electrons between hydrogen and chlorine atoms, partial positive and partial negative poles exist and are referred to as dipole, or the more electronegative atom becomes partially negative and has the most electron density, whereas the least electronegative becomes the partially positive and has the lesser electron density. Because of the pole of opposite charges attracts, the partial negative end, for example, of the chlorine atom in hydrogen chloride will be attracted to the partial positive end of the hydrogen atom. This force is weaker than the ionic and hydrogen bonds. All polar molecules have a partial negative end and a partial positive end which are attracted to each other. The resulting forces is called dipole-dipole forces and is much weaker than the ionic and covalent bond. Next types of intermolecular forces is the ion dipole forces. Ion dipole forces exist in the attraction between a charged particle called ion, which can be a positively charged cation or a negatively charged anion, and polar molecules. This exhibits in hydration, or the interaction of water molecules with ions and anions of ionic compounds in water. So what is a ion dipole interaction? Ion dipole forces are involved in solutions which So what is an ion dipole interaction? Ion dipole forces are involved in solutions where an ionic compound is dissolved in a polar solvent, like that of a solution of a table salt in water. So table salt is the ion or the molecules or the compounds that consist an ion, and water is the dipole molecule. Note, this must be a solutions and not a pure substance since they involve two different species. An ion in a sense of table salt and a polar molecules in case of water. So Na positive when sodium chloride or salt is dissolved in water, sodium chloride will dissociate in sodium cations Na+ and chlorine ions or Cl or chloride. Because water is a polar molecule and has a partial negative and partial positive poles, the sodium cations will form an ion dipole interaction with the negative part of the molecule, which is the oxygen, while the chlorine anions will form an ion dipole interaction with the positive part of the water molecules, which is the hydrogen. The ion force exists in the attraction between ions and dipole molecules. The partial charges at the end of the dipole molecules can make an ion-dipole interaction. Third type is the dispersion forces or the London forces. It is the weakest attractive force formed due to the temporary dipole induces in nonpolar molecules. It also called as the induced dipole-induced interaction. Okay, so dipole forces explains how polar molecules can attract each other, but it is a bit harder to account for the forces of attraction which exist between completely nonpolar molecules. Even the noble gases whose atoms do not form chemical bonds with each other can be condensed into liquids at a sufficiently low temperature. According to his theory, when two molecules approach each other very closely, the motion of the electrons in one of the molecules interferes with the motion of the electrons in the other hand, and the net result is an attractive force. For example, if there is an ion or a polar molecule near an atom or nonpolar molecule, there will be a distortion of the nonpolar molecule due to the force exerted by the ions or the polar molecule. This distortion will result in temporary dipoles in the nonpolar molecules, which is called induced dipole. Induced dipole is the separation of the positive and negative charges in a nonpolar molecule due to its nearness of an ion or polar molecule. On the other hand, when the induced dipole is due to the interaction between an ion and nonpolar molecule, the interaction is called ion-induced dipole interaction. When the induced dipole On the other hand, when the induced dipole is due to the interaction between a polar and nonpolar molecule, the interaction is called as dipole-induced dipole interaction. Next, the last type of the intermolecular forces, which is the hydrogen bond. Hydrogen bond is a special type of dipole-dipole interaction between the hydrogen atom in a polar molecule and the highly electronegative atoms, nitrogen, chlorine, and oxygen, in another molecule. The water is a very good example of a substance that exhibits hydrogen bonding. The electronegative atoms like oxygen cause the bond to be polar. These atoms becomes slightly negatively charged, and hydrogen atoms becomes slightly positive charged. Thus, a dipole exists.